In early November 2025, a quiet signal arrived from deep space, unnoticed by most of the world. At a ground station in Inner Mongolia, Chinese engineers monitoring the Tianwen-2 Mars orbiter detected a narrowband anomaly in the returning data stream, an irregular reflection from an object near the planet's orbital path. Initial analysis identified it as a cometary body, but one whose orbit made no mathematical sense. Within hours, the object was cross-referenced with international databases and tentatively matched to a name that had long since slipped from headlines: 3I/Atlas, an interstellar comet first discovered years earlier and believed to have vanished into the dark beyond Jupiter. The rediscovery was more than an astronomical curiosity. The object's return path was unnatural, deviating sharply from models that governed ordinary celestial mechanics. In the following days, Chinese scientists released only fragments of information, a series of faint spectral readings, some short-range telemetry from Mars orbit, and a note indicating that the comet's composition appeared anomalously ancient. That phrase ignited the world's attention. By November 4, the global astronomical community was in motion. Observatories from Chile to Hawaii recalibrated their instruments. Early data revealed a nucleus far denser than expected, reflecting sunlight in irregular pulses. Spectral lines showed a mixture of isotopes inconsistent with any known comet within the solar system. Ratios of carbon to nitrogen, oxygen to silicon, every element told a story older than the planets themselves. A memo circulated through the European Space Agency quietly stated that 3I/Atlas could have formed before the Sun's accretion disk ever coalesced. News agencies caught on almost instantly. BBC World ran its first report that same evening. China's Mars orbiter detects interstellar object, older than the solar system. The story dominated every major network within hours. The tone of coverage was cautious at first, almost reverent. But the calm eroded as the object's projected orbit was refined. By November 6, simulations suggested it would pass within the inner solar system, closer to Earth than any interstellar visitor in recorded history. In Beijing, the discovery became a symbol of technological triumph. State media celebrated Tianwen-2's precision, though independent researchers noted discrepancies between public and leaked data. In Washington, NASA officials requested full transparency, invoking international agreements on deep space data sharing. The request went unanswered for 2 days. That silence stirred suspicion. A classified report later obtained by European journalists revealed that the United States had interpreted China's restraint as deliberate, an attempt to control the narrative of what could become the century's most significant scientific discovery. Meanwhile, global markets trembled. The headlines alone were enough to trigger volatility. Ancient comet returning from beyond the stars, trajectory uncertain, NASA confirms Earth-crossing orbit possible. Economists described it as the first space-induced market shock in history. Fear of the unknown, magnified by 24-hour media loops, began to erode public composure. Behind the scenes, space agencies raced to model the comet's movement. The data was maddeningly inconsistent. Its spin rate shifted irregularly, as though some internal process was changing its angular momentum. Instruments at the Atacama Large Millimeter Array detected volatile plumes erupting from the surface, jets of carbon monoxide and ammonia expanding far faster than standard thermodynamic models allowed. One researcher at the Max Planck Institute for Astronomy summarized it bluntly: it behaves like an object that should not exist. On November 8, the European Space Operations Center in Darmstadt released a technical bulletin estimating the closest approach date, December 2, give or take 3 days. The margin of error was wide enough to keep anxiety alive. Private space companies seized the opportunity for attention. SpaceX announced an emergency scientific mission concept to send a Starship-class probe to intercept the comet, though no one believed it could be launched in time. Still, the mere suggestion that a private corporation might attempt contact with an interstellar object deepened the sense that something momentous was unfolding beyond anyone's control. Across the Atlantic, American officials tried to project calm. The White House Science Advisory Board stated that no evidence currently indicates an impact trajectory. Yet in the same week, leaked documents showed NASA quietly revising its contingency protocols for deep space impact events. Internally, probability models gave a non-zero chance, less than 1 in 100,000, that gravitational perturbations could shift 3I/Atlas into a dangerously close orbit. To the public, those numbers sounded reassuring. To physicists, they were cause for sleepless nights. European and Asian media began describing the comet as the messenger. Documentaries were rushed into production. Scientific conferences were cancelled and replaced with emergency teleconferences. At the International Astronomical Union, committees debated whether the reappearance of 3I/Atlas meant it had been gravitationally captured by the solar system. If true, it would be the first permanent interstellar object bound to the Sun. Others speculated about the nature of its composition, metallic inclusions, magnetic resonance signatures, and faint radio emissions that seemed to repeat at irregular intervals. None of it added up to anything familiar. By November 10, the object was bright enough to be visible through small telescopes. Amateur astronomers began uploading images, a narrow, green-tinged streak against the stars, its coma expanding asymmetrically. Experts explained the color as ionized carbon, but the asymmetry was harder to account for. Some believed the comet was shedding mass unevenly, others suspected fragmentation. The possibility of multiple nuclei triggered quiet panic in observatories worldwide. Fragmentation could mean unpredictable trajectories, and unpredictable trajectories meant risk. Political pressure mounted. The United Nations called for an emergency session on space monitoring transparency. Chinese officials reiterated that there was no threat to human safety. In Washington, analysts disagreed, warning that incomplete data made such assurances premature. European leaders urged restraint. Moscow remained silent. For the first time since the Cold War, every major power pointed its most sophisticated instruments toward the same point in the sky. As the nights grew shorter in the northern hemisphere, 3I/Atlas became a public spectacle. Crowds gathered before dawn to glimpse it rising above the horizon, a pale slash of light that moved imperceptibly from night to night. It was no longer the domain of scientists, it had become a cultural phenomenon. Television anchors described its approach with the vocabulary of disaster films. Social media turned it into a symbol of both wonder and dread. By mid-November, a new layer of tension emerged. Observatories in South America detected fluctuations in the object's radio profile, bursts of low-frequency energy consistent with static discharge across metallic surfaces. The readings were subtle but undeniable. Some theorists suggested the comet contained traces of ferromagnetic compounds, relics from a long-dead stellar system. The story gained traction in mainstream outlets under the headline, "Magnetic Ghost from Another Sunday." For days, that phrase dominated search trends. In Europe, the tone shifted from scientific curiosity to existential anxiety. Economists warned that insurance markets were quietly factoring in low-probability orbital events. Governments avoided using the word impact, yet private sector risk models were already running simulations for near-Earth debris fallout. In Beijing, the Central Committee ordered state media to reduce coverage, replacing comet stories with reports on agricultural initiatives. The censorship backfired, rumors flourished online. Some users claimed the object was on a collision path. Others insisted it had slowed down, as if resisting gravity. None of these claims were substantiated, but each found an audience. On November 17, the European Southern Observatory released new images taken with the Very Large Telescope. They showed something unexpected. The nucleus had fractured into two visible pieces, trailing a thin bridge of dust and vapor. The discovery reignited panic. Journalists demanded statements from every major agency. NASA confirmed the split but downplayed the risk, describing it as a natural evolutionary stage of volatile outgassing. Experts interviewed later admitted privately that such bifurcation was rare and unpredictable. The change altered the trajectory once again, rendering previous simulations obsolete. International cooperation began to crumble under the weight of secrecy. Data sharing slowed, briefings were postponed. In Washington, advisors accused Beijing of withholding high-resolution imagery from Tianwen-2's onboard spectrometer. In Beijing, officials accused Western agencies of manipulating orbital data to justify militarizing low Earth orbit. Each side denied the allegations, yet the mistrust was palpable. Science had turned political, and politics had turned cosmic. By the final week of November, the comet's tail had grown visible to the naked eye, arcing across pre-dawn skies like a luminous scar. Observatories reported surges of activity in its core, outgassing, chemical transformations, and periodic brightening events every 6 hours. Astronomers speculated that internal heating might cause further fragmentation. The public followed every update with morbid fascination. Religious leaders issued statements about humility before the universe. Economists spoke of resilience. Politicians invoked unity. None of it dispelled the unease. On November 23, the Tianwen-2 orbiter transmitted its last confirmed data sequence before entering safe mode. The final image showed the two fragments of 3I/Atlas rotating irregularly, surrounded by clouds of frozen dust illuminated by the distant sun. Scientists could not determine whether the signal loss was due to technical failure or deliberate shutdown. The last entry in the mission log simply read, "Telemetry unstable. Observation pending." The world waited. Night after night, the comet grew brighter, approaching the inner orbit of Mars and edging toward the space between Earth and the Sun. Satellite monitoring networks reported subtle gravitational perturbations, measurable deviations in the orbits of small near-Earth objects. The changes were tiny but real, confirming that 3I/Atlas carried far more mass than early models assumed. It was not a fragile ball of ice, it was something heavier, ancient beyond reckoning, moving silently through the dark. By November 25, the BBC, CNN, and Al Jazeera broadcast continuous live coverage. The footage showed millions of people standing outside at dawn, gazing upward at the same streak of light. Scientists spoke in measured tones, repeating that the probability of impact remained extremely low. Yet no one seemed reassured. The fear had evolved into something quieter, a collective awareness of human smallness against the vast indifference of space. That night, observatories across 3 continents captured simultaneous brightening events, followed by a sudden dimming. The data was ambiguous. Some instruments recorded a faint shift in the object's spectral output, suggesting new material exposure. Others showed nothing unusual. At 23:40 Universal Time Coordinated, NASA's Jet Propulsion Laboratory released a single-line bulletin, "Trajectory refinement in progress. Update at midnight UTC." The update never came. When dawn rose over the Pacific, the comet still shone, pale and unwavering, its path uncertain. No official confirmation arrived. The world continued to watch, suspended in that narrow space between knowledge and fear. In cities and villages alike, people stepped outside to stare at the silent visitor, tracing its faint arc across the morning sky. It was not the end of the world, at least not yet. It was something older, something colder, a reminder that beyond the fragile shell of Earth's atmosphere, the universe moved on, vast and indifferent, carrying with it the relics of creation itself. And as the day brightened, 3I/Atlas continued on its path, ancient, unbroken, and unknown, drifting toward the inner system, while humanity, for the first time in generations, could do nothing but look up and wait. By the final days of November 2025, the world had settled into a strange rhythm of silence and observation. Every continent, every major city, every television channel revolved around a single question that no one could fully answer: how close will it come? The data blackout from both Chinese and American agencies deepened the uncertainty. The last official coordinates were 3 days old, and beyond them, no one could say for sure where 3I/Atlas truly was. Civilian astronomers, working with modest telescopes, began producing their own projections, overlaying star maps with speculative lines and points of light. None of them agreed. Each estimate only widened the sense that human understanding had reached its edge. In Europe, the skies remained unusually clear for the season. People gathered before sunrise in quiet clusters, wrapped in coats, holding thermoses of coffee. The air was cold and still, the horizon glowing faintly green. Above it, the comet hung like a wound in the heavens, a gash of light that seemed to pulse ever so slightly, as if breathing. News anchors described it as the most photographed object in history. Scientists avoided superlatives, but even they spoke of awe tinged with disbelief. Governments began issuing practical guidance, though none of it referred directly to danger. Power companies were advised to inspect grid systems for electromagnetic resilience. Satellite operators received instructions to prepare for potential communication interference. Air traffic controllers were told to maintain contingency protocols for atmospheric anomalies. The language of bureaucracy had become a thin disguise for collective anxiety. At the European Space Operations Center, a joint team from ESA, NASA, and Roscosmos worked through consecutive nights. The latest radar pings indicated that the larger fragment of 3I/Atlas, designated A, was decelerating slightly under solar pressure. The smaller fragment, B, was tumbling faster, its outgassing more erratic. Simulations predicted that if either fragment continued to lose mass asymmetrically, its orbit could destabilize, pulling it closer to Earth's gravitational field. The probability remained small but measurable. That was enough to keep every analyst awake. Around November 27, faint meteor activity began lighting up the skies over the southern hemisphere. In Argentina, pilots reported streaks of light radiating from the direction of the comet's trajectory. The fragments were microscopic, dust and ice grains, harmless but unmistakable. The first tangible evidence that 3I/Atlas was shedding material into Earth's orbital path. Observatories confirmed that the debris would not pose a threat, yet the symbolic meaning was impossible to ignore. The interstellar visitor was leaving a trail behind, as though marking its passage through human history. Global attention reached fever pitch. Financial markets fluctuated wildly. Religious leaders called for unity and reflection. In cities from Los Angeles to Seoul, massive outdoor screens broadcast live sky feeds. Some saw it as a scientific milestone, others as an omen. In online forums, conspiracy theories took on lives of their own, claims that the object was hollow, that it emitted structured radio pulses, that world governments were hiding an impact forecast. None of it could be proven, but in the absence of certainty, fear became its own form of truth. The final official press briefing came from NASA on November 29. The spokesperson, exhausted after days without rest, repeated what had become the world's most hollow reassurance: the trajectory remains under observation. No evidence currently indicates a direct threat to Earth. The phrase was broadcast on every network, its monotony failing to conceal the tremor in her voice. That night, a mild geomagnetic disturbance rippled across the planet. Auroras appeared farther south than usual, painting the skies of New York, Paris, and Tokyo in faint veils of green. Scientists attributed it to solar activity, but many observers noted the timing. The auroras peaked precisely as 3I/Atlas reached its point of greatest brightness. For several hours, night seemed to glow from within. Cameras captured the surreal combination, the comet arcing across the heavens while the Earth's own atmosphere shimmered in response. In that eerie light, the boundaries between knowledge and wonder blurred completely. Humanity stood united in uncertainty, billions of eyes lifted to a single moving point in the dark. The comet's tail spanned the horizon. It was visible even through the haze of cities, cutting through light pollution as if ignoring civilization itself. Astronomers noted its unusual steadiness, the absence of flicker or flare, as though the object had stabilized, indifferent to gravity, indifferent to time. On December 1, radio telescopes around the world picked up a faint burst of electromagnetic noise originating from the region of space where the comet was expected to pass. It was brief, only minutes long, but rich in frequencies, like static layered with harmonic tones. Analysts debated whether it came from the comet itself or from interference caused by solar particles scattering through its ion tail. No conclusion was reached. The data was filed, timestamped, and transmitted to every major research institution on Earth. Then silence resumed. That same night, the comet's magnitude peaked. In the deserts of Nevada, thousands gathered in silence as the green-white arc reached its zenith. For a few moments, it was bright enough to cast shadows. A satellite feed from the International Space Station showed Earth's limb framed by the long, luminous streak, like a bridge between two epochs, the ancient and the present. Astronauts, following procedure, recorded the view without commentary. By the next dawn, the brightness began to wane. Telescopes detected a subtle change in trajectory, consistent with a slingshot around the inner solar system. It seemed that 3I/Atlas would not collide. It would not stay, either. Its orbit was bending, preparing to depart once again into interstellar space. The relief that should have followed never fully came. The silence was too heavy, the unanswered questions too many. No one could explain how an object from outside the solar system could have returned, following a path that physics barely allowed. No one could determine why its spectral composition defied known models, or why it fractured precisely as it entered the region near Mars. The mystery remained, suspended above human comprehension. In the early hours of December 3, the comet was no longer visible to the naked eye. The sky returned to normal, but something in the human psyche did not. Scientists resumed their work. News outlets shifted focus. Yet the feeling of having glimpsed something impossibly ancient lingered, a reminder that the universe did not revolve around human certainty. In Beijing, Tianwen, too, remained silent. In Pasadena, engineers continued to analyze fragments of data from the Deep Space Network, searching for patterns. In Geneva, astrophysicists drafted papers they knew might never be reviewed before the next cosmic event rewrote them. Across the planet, ordinary people scrolled through the last photographs, taken on cold November mornings when the world held its breath beneath a foreign light. No conclusive announcement ever came. There was no final trajectory update, no definitive explanation. Only scattered reports that, weeks later, faint traces of 3I/Atlas's dust stream were still being detected in the upper atmosphere, microscopic relics of an object older than the Sun itself. Then the world moved on, as it always does. Yet for those who had watched the sky in those quiet, electric nights, a single truth endured: the universe had looked back, if only for a moment. And in that moment, humanity had understood how fragile its certainty really was, how brief its grasp on the vast, indifferent clockwork of creation. And somewhere, far beyond the orbit of Neptune, a fragment of 3I/Atlas continued to drift through darkness, silent and slow, carrying within it the dust of forgotten stars and the unanswered questions of a world that had watched, waited, and learned nothing certain at all. Weeks after the comet's retreat into the outer darkness, the world's observatories continued to record traces of its passing, ionized trails, flickers of charged dust still orbiting loosely near Earth's path. Though the headlines had faded, the scientists did not stop. The data left behind by 3I/Atlas refused to settle into meaning. Its numbers broke patterns that generations of astrophysics had taken for granted. Ratios that should have matched the chemistry of deep space ice came back skewed. Isotopic weights fell outside established models by margins too wide to be error. In Beijing, the recovered telemetry from Tianwen-2's final transmission was still being analyzed in secret laboratories. The orbiter's loss had been explained officially as radiation interference, but the data packets sent before that failure contained readings so compressed they resisted decompression. Rumors began to circulate in the scientific underground that the compression had not been accidental, that it was a form of encryption, a deliberate attempt to restrict access until higher approval. The CNSA denied the claim, but the speculation persisted. Across the Pacific, in Pasadena, the Jet Propulsion Laboratory convened what it called a post-approach anomaly review. The goal was simple: to understand why every model of the comet's motion had failed. The results were inconclusive. A final note in the internal summary read, "Observed mass-to-momentum ratios exceed all known parameters. Source of deviation, unknown." In Europe, the Max Planck Institute began reconstructing 3I/Atlas's chemical signature using spectrographic fragments from dozens of observatories. What emerged looked impossible: clusters of elements bonded in forms never stable under the pressure and temperature conditions of known space. The report concluded that the material must have been forged in an environment different from any found in the Milky Way. It was a conclusion so bold that even its authors refused to attach their names. Public attention, however, had already shifted. The world economy had absorbed the shock, markets stabilized, the news cycle moved on. Only in small scientific circles did the debate continue, quietly and obsessively. Conferences were held under bland titles: interstellar dust and the new composition models, non-standard isotopic distributions in deep space objects. Behind those neutral names, the discussions were frantic. Something had passed through the solar system that should not have been able to, and no one could explain how or why. In Washington, a Senate committee demanded classified briefings from NASA, the Department of Defense, and the intelligence community. The question was not whether the comet had posed a threat, but whether anyone had learned anything that could become one. The language was bureaucratic, but the motive was clear. Information was power, and power meant control over the next discovery, should it come closer. Winter deepened. The dust from 3I/Atlas continued to fall invisibly through the upper atmosphere, mixing with terrestrial particles. Some researchers proposed a coordinated collection effort using high-altitude balloons to capture remnants. By mid-December, microscopic samples began appearing in laboratory filters, tiny grains of carbonaceous material with isotopic ratios that defied classification. When examined under electron microscopes, the particles looked fractured, as if they had been under immense pressure for billions of years, then suddenly released. In Geneva, a small team at CERN ran simulations on the atomic structure. Their models failed. The matter behaved as though its binding energy had been calibrated under a different set of universal constants. "It is not alien," one physicist told a BBC science correspondent. "It is simply older than our physics." The comment aired once, then disappeared from archives within hours. Elsewhere, other anomalies surfaced. Satellite sensors detected faint, lingering electromagnetic interference along the path the comet had taken. The interference was diffuse, fading slowly, but measurable, like static after a lightning strike that refused to die out. Some suspected remnants of the comet's ion tail, others whispered of something else, a kind of residual signature from the deep interstellar medium that had never before entered the solar environment. By late December, the phenomenon had diminished to background noise. Observatories moved on to new targets. Papers were written, then quietly withdrawn. The world's attention returned to the rhythms of politics and commerce. Yet among those who had watched the data firsthand, the memory did not fade. A sense of quiet unease lingered, the feeling that something immense had brushed past humanity and continued on, indifferent and unreadable. In January, a final conference was held in Vienna under the title, 3I/Atlas, Lessons from an Interstellar Encounter. Representatives from 20 nations attended. The tone was subdued, almost reverent. No one claimed victory. The consensus statement, drafted over 3 days, offered only a single conclusion: further study is required to understand the origin and behavior of objects beyond solar genesis. It was the most cautious possible phrasing for a mystery that had shaken the foundations of cosmology. Outside the conference hall, snow fell in slow spirals, bright under the streetlights. Reporters filed their closing lines. The world, they wrote, had survived an encounter with the unknown. Yet for many who had followed the data from the beginning, survival was not the question. The question was what had changed, subtly, invisibly, since that November when an object older than the sun had passed near enough to touch with light. In the cold upper air, fragments of its dust still glowed faintly when struck by sunlight. Meteorologists noted the effect occasionally, mislabeling it as noctilucent cloud reflection. In truth, the particles were foreign to Earth, relics from before the planets had names. They would drift for decades, maybe centuries, before gravity and weather pulled them down to join the soil. Somewhere beyond the orbit of Neptune, beyond the edge of any telescope's reach, 3I/Atlas continued its long escape. The two fragments, once one, now traveled separately through the void, mute, patient, each carrying the record of its impossible journey. Between them stretched millions of kilometers of silence, and behind them, a faint trail of matter that marked the moment when the universe reminded a single planet how little it knew. Astronomers kept their eyes on the data feeds. Once every few weeks, a tiny echo appeared on the farthest sensors, a flicker in the background radiation, a whisper of something moving outward. Whether it was the comet or just the noise of space itself, no one could tell. Yet they logged every instance, timestamped every signal, unwilling to let go of the story that had begun with a pulse of reflected light near Mars and ended with a question that had no answer. And as winter passed into spring, humanity continued its routines, launching satellites, trading markets, planning the next missions to the Moon and Mars, while somewhere in the infinite dark, the ancient visitor drifted farther, slower, colder. It carried with it no message, no warning, only a silent record of existence written in dust older than light. In archives across the world, the final images from 2025 were stored, the green streak across the dawn sky, the blurred outlines of twin fragments, the frozen horizon under their light. Historians would later call it the year the universe came closer than ever before. The scientists, when asked, would give no such title. They would say only that something passed through, something that left the instruments richer and the world smaller, and that in its wake remained a single, unresolvable truth. The more humanity looked into the cosmos, the less it understood its own place within it.